Hey, let's do ellipses today, and I need you to have a few different colors. I think we're going to need at least 4, if not 5 colors today to help you really label what's going on when we're talking about ellipses. Remember that an ellipse, if we're cutting into a cone, an ellipse looks like this. If I were to slice it this way with a plane, I would look like this for an ellipse, or it could possibly look like a vertical ellipse. Remember, one that's sideways and bigger horizontally is called a horizontal ellipse, and this one's a vertical ellipse. It's going to be important for us to differentiate between those two. So let's go ahead and jump in. Let's draw a horizontal ellipse first. Okay, we're going to draw it this way. And this one's going to be a vertical ellipse. Now, vertical and horizontal ellipses have all the same parts to them, but there's one distinct difference, and that's what their equation looks like to give them either the horizontal distance or the vertical distance bigger. Both of them have a center of h comma k. Okay, so that center is going to be in the middle. Both have the same center. Okay, both of them also have something called vertices. So vertices are going to be what's called along the major axis. And let me show you what that looks like here. This is for our major axis. I'm going to go ahead and put that in purple. But the major axis just means it's the axis that looks like it's the longest, and it goes through the center. So it's for both of these. Those are the major axis, longest axis. And the major axis is double the value of A. So from the center to what's called the vertices hit the ellipse and the major axis. So these are both called vertices. Vertice here and a vertice here. The distance to the vertice is A from the center. Okay, so A from the center horizontally. So that means our vertices are going to be on the horizontal direction, are going to be h plus or minus a comma k, and for the vertical direction they're going to be h comma k plus or minus a. Okay, so that's how we're going to find both of those vertices depending on which one it is. We also have a minor axis here, and a minor axis is the shorter axis. Whoops. It's the shorter axis, so it's going to put that in green right here. And that's the distance of B. So the minor axis is the distance to B, and it's the shorter axis. So on the horizontal ellipse, it's the vertical axis. And on the vertical ellipse, it's the horizontal axis where those distances are B. And where the minor axis hits the ellipse, those are our co-vertices. So along the minor axis, I'm going to add this in, there's something called co-vertices. So these are co-vertices. And for the horizontal ellipse, the co-vertices are h comma k plus or minus the b value. And for the vertices, the vertical ellipse, it's going to be h comma h plus or minus the b value comma k. It's a little different. And then so we talked about our minor axis. That was in green, so I'll highlight that. And then last but not least are the foci. And we'll go ahead and put the foci in orange. The foci are along the major axis a distance of C from the center. So here's our major axis in the purple, and that's a distance of C, that's our foci. And our distance here is C. Again, on the major axis on the vertical, that's our foci points, and those distances are C from the center. And we know C comes from, I'll put this over to the side, C squared always is the value of A squared minus B squared. Remember, A is the distance from the center along the major axis, B is the distance from the center to the minor axis. So remember that in ellipses, for all ellipses, A is always greater than B, and that's part of what tells us the direction that it's going. All right, so now that we have that all labeled, let's fill this in. So an ellipse is a set of all points X and Y in a plane where the sum of distances from 2 points, or 2 distinct points, called foci, which we see in our graph there, is constant. Okay. So let's talk about the standard form of the equation with the center h comma k for the horizontal major axis. Remember, this is going to look like the hamburger or the horizontal direction. So we're going to say this is x minus h squared all over a squared plus y minus k squared all over b squared equals 1. And I'll go ahead and just be consistent. H is in red, k is in blue. And what color did we use for A? We used purple for A. And we used green for B. Okay. And then the standard form of an equation for the center of h comma k with the vertical major axis. Remember this is a vertical ellipse where this was the horizontal. Let's go ahead and write that one out. This one's going to be x minus h squared all over b squared plus y minus k squared all over a squared equals 1. Remember, h is in red, k is the y coordinate of the center in blue, b is still in green, and a is still in purple. So if you want to highlight, label, however you want to do it so it's color-coded. And then remember, our foci lie on the major axis, c units from the center, where c squared equals a squared minus b squared. And remember, a is always greater than b in an ellipse. And then if the center's at the origin, remember h comma k, that means it's not going to change the x or the y values. So we can use for the horizontal ellipse, it would look like x squared all over a squared plus y squared all over b squared equals 1. And for the vertical, centered at 0, 0, it'd be x squared all over b squared plus y squared all over a squared equals 1. Where there's no h and k, but a is the distance to the major axis and b is the distance to the minor axis. Okay. And then let's go down to the next one. We're going to sketch the ellipse given by 4x squared. So 4x squared plus 25y squared equals 100. So keep in mind, our two equations that we're looking at are x minus h squared all over a squared plus y minus k squared all over b squared equals 1. And that's for our horizontal, or we know x minus h squared all over b squared plus y minus k squared all over a squared equals 1. Clean that up. So this is a horizontal ellipse. This is a vertical ellipse. Let's see which one this is. First of all, I see here there is no 1. It's a 100. So I need to make that 100 into a 1. So we're going to divide everything by 100 to get that 1 that we need. So we know 100 divided by 100 is 1. 4 and 100 can reduce. So if we want to reduce that, 4 and 100 can both be divided by 4. So I get a 1 and a 25. And then 25 and 100 can reduce by 25. So we end up with 1 and 4. So I'm going to rewrite this as x squared over 25 plus y squared over 4. So now here's what you're going to do. We notice a couple of things. We notice that x is by itself. There's no minus h, and y is also by itself. There's no minus k. That's good news. So now we're going to look at the denominators. So we know our center is at 0, 0. So now we're going to decide, okay, what's the value of a? Now remember, a is always the bigger value. So I see here 25 is bigger. So I know a squared equals 25. Well, how do I know what a is? I'm going to take the square root of both sides and I get a equals 5. So my distance to the major axis is going to be 5. And my distance to the vertice as well. I also know here is going to be my b squared. That's our smaller distance is 4. So the square root of both sides, I get b equals 2. So let's go ahead. We also recognize that our bigger value, a squared, was under the x. Because of that, we know this is going to be a horizontal ellipse. So let's draw our center at 0, 0. Our distance to the major axis along A is going to be in the horizontal direction, 5 to the right and 5 to the left. So we're going to move over 1, 2, 3, 4, 5. That's my vertices. And to the left, 1, 2, 3, 4, 5. My other vertex. Remember, this is our center. And then in the minor direction, we're going to say going up 2. So 1, 2, 1, 2. Those are my co-vertices. And now that I've got those 4 points, we can connect those dots and get our ellipse. And that's all we have for today. See you back in class.